All right, welcome back, Algebra 2. We're still continuing on with the Chapter 7 review. I may have said that I'm going to make this the final video. I lied. I'm actually going to make one more after this, just because I don't want to make this like a 20-minute video for you. All right, so for this one, we are going to do numbers 13 through 17, because 17 is kind of a longer one. Okay, we want to solve this equation, number 13, 3 to the 2x equals 243. Here we go. Here's how I'm going to start. I'm going to use a logarithm to help me solve. I'm going to say log base 3 of 243 is equal to 2x. Now, this is actually a super nice number. It's 5. 5 equals 2x. If you divide by 2, I'll show that algebra quick. So x is 5 divided by 2, or if you want to write it as a decimal, 2.5. Either one's acceptable. Now, number 14, we've got two different numbers. We've got 16 and 64. We have 16 to the 2x minus 2 power equals 64 to the negative 2x minus 3rd power. So I'm going to see if I can rewrite 16 and 64 to have the same base. In other words, if it's the same number raised to a different power, that's how I get 16 and 64. And I see that 4 lives in each one of them. 16 is 4 squared. So we got 4 squared to the 2x minus, whoa, what happened there? Let's try that again. 2 to the 2x minus 2, there we go, equals 64 is 4 to the 3rd to the negative 2x minus 3. There we go. Now, I need to distribute the 2 and the 3 through each set of parentheses. So we really have 4 to the, not the 6, I'm getting ahead of myself, to the 4x minus 4 equals 4 to the negative 6x minus 9. There's that 6. Now that they have the same base, I can just kind of forget about those 4's there. So we got 4x minus 4 equals negative 6x minus 9. This is pretty straightforward algebra. We add the 6x to both sides, and I'm going to add 4 to both sides. So goodbye and goodbye. So that leaves us with 10x equals negative 5. If you divide, x is negative 1/2. 15 and 16. We're going to start with number 15. Before I do anything for solving for that variable, I need to add 10 to both sides. It's called isolating it. So we have 8 to the n minus 8 minus, there we go, equals 48. And here I'm going to use logarithms to help me solve. I'm going to use the log base 8 of 48 equals n minus 8. Now this one isn't necessarily a nice number. You'll get a decimal here. You'll get something along the lines of 1.862 equals n minus 8. I think I went a little further on my answer key, but to the thousandth is, I think, okay. If you add 8 to both sides, you'll get n equals 9.862, roughly, and there you go. That's number 15. Number 16, let me get a dividing line in there. There we go. I have log base 7 of 2x minus log base 7 of 4 equals log base 7 of 52. Now, I want to focus on this guy right there. I see a subtraction. I'm going to rewrite this as a not as a product, as a quotient. So log base 7 of 2x divided by 4 equals log base 7 of 52. Now, why did I condense that on the left? so that I can just ignore the log base 7 and solve the following equation. 2x divided by 4 equals 52. There is another way to solve this. I find this one to be the quickest and most efficient, and probably the one that you're most familiar with. So we multiply each side by 4, and we get 2x equals, what is that, 208? Divide that by 2, you get x is 104. So number 17 now. This one's a little bit trickier because we have an extra step that we need to do. Once we find our solutions, because there are 2 that you'll find, we need to check for extraneous solutions. So here we go. I'm going to see if I can zoom in a little bit. A little bit more. A little bit more. Keep going. Aha, perfect. That way I've got a little bit more space to write on. So we got log base 3 of x plus 8 plus log base 3 of x plus 26 equals 5. I'm going to focus on this first, and I'm going to condense it. I'm going to write it as a product. So log base 3 of x plus 8. Now, in fact, I'm going to put square braces around this because I'm using too many parentheses. And x plus 26. All of that is supposed to be equal to 5. Now, I'm going to simplify what's in my square brackets. So we have log base 3 of the following product. Here we can use FOIL, or we could use the box, whichever one you're more comfortable with. In either case, you'll end up with x squared plus 34x plus 208. All of that is supposed to be equal to 5. Now here's where I go. To solve, I say 3 to the 5th is equal to what's in the parentheses. X squared plus 34x plus 208. 3 to the 5th, you guys, is 243. So 243 is equal to x squared plus 34x plus 208. You may see where this is going by now. Subtract 243 from both sides. And let's scroll down, because I am running out of room a little bit. We have x squared plus 34x. 208 minus 243 is minus 35. And now we need to factor this. You can use the diamond method. You could use the guess and check. I can use guess and check here. It's x plus 35 times x minus 1. So that means my 2 potential answers are x equals negative 35 and x equals 1. Now, like I said, we need to check for extraneous solutions. We need to check both of them. We may find that one of them is extraneous. We may find both of them are extraneous. Or we may find none of them are extraneous. So here we check for extraneous solutions. I'm going to put a question mark by it because we don't know if any of them are extraneous yet. I'm going to check x equals 1. Now, I'm going to plug in 1 into my original equation. So I've got log base 3 of 1 plus 8 plus log base 3 of 1 plus 26. All of that's supposed to be equal to 5. 1 plus 8 is 9. So we got log base 3 of 9 plus log base 3. 1 plus 26 is 27 equals 5. You can use a calculator if you want. Log base 3 of 9 is 2. Log base 3 of 27 is 3. 2 plus 3 certainly does equal 5. So 1 works. 1 is not extraneous. Now we need to check x equals negative 35. So once again, plug in everything into the original equation. Log base 3 of negative 35 plus 8 plus log base 3 of negative 35 plus 26. Whoops. Getting ahead of myself again. It's supposed to be 26. That's supposed to be equal to 5. Negative 35 plus 8 is negative 27. Negative 35 plus 36 is negative 9. 3 to the negative third power is negative 27. This guy right here is where we run into problems. There is nothing we can raise 3 to get negative 9. This does not exist. Therefore, x equals negative 35 is extraneous. Do not forget to check for extraneous solutions. Hopefully there are directions on the test for you once you get it that'll remind you to do that. If it doesn't, make sure you check for extraneous solutions because not everything will work. So anyway, that wraps up number 17. Stay tuned for the last 5 problems, 18 through 22. Be back at you in just a second.